maybe don't forget about it. That's pretty much it. There should be some permanent markers, I think. No? Yeah. So feel free to put your ideas on the board.
So, first thing NI's going to regret is not reviewing the. That's the safe page. The next page is porn sites I like. But yeah, you're kind of told to do this stuff, but this is the one you skirt over. If we've got time, I'll show a video of our user group award, because we got best advanced user group. So, co-authored that, been alliance partner. That's a joke. I tweet sometimes, and I've done these presentations. Now normally I don't do a presentation twice, but I'm doing this one. I like this one. If you don't like it, I don't care, I like it. So sometimes at CLA summits I feel like I have to justify myself. So I've done lots of stuff. Actually, I've watched Adrian do lots of stuff. These are mostly his projects, none of mine actually work out. And I've done it quite a long time, so a lot of my views do have some background in deliverable items, which is... So if you're at the CLA Summit, I have changed some slides so you can pay some attention, but this is one that I did before. We're going to cover the first two. No one knows all the requirements. No one can fully understand or predict all the interactions. The other ones, come and talk to me about after. I have opinions. There's articles to come on those, I think. But yeah, life is full of things we don't understand. So this started off. I've removed a couple of slides, but actually the first slide I showed at the CLA Summit was the lady who did Ada Lovelace did the Babbage machine, and there was a letter by her whinging about how much debugging she did. I think it was like 1846. And so we've been debugging a long time, and actually that's not a bad thing. See, a bug is a bad thing, and debugging is a bad thing, and
debugging is good.
Well, that's what I think. And being able to debug easy is good.
Yeah.
But this is quite a nice thing. So this was in 1946. He hadn't discovered debugging yet, but he knew that he'd be spending a great deal of time messing around with the thing he built. And the reason why we do so much debugging is that it's quite hard. You know, it's not an easy thing. We're making shapes in clouds. You know, it's not an easy thing. This is quite good. Find that link. It's funny. It's a very tortured programmer. Made me laugh anyway. And to back it up, here's some actual real data. So this, I forget to go onto my pages so I don't have my notes. So this is a study of quite a lot of projects. I think it's 500 American companies. And what you see here, these aren't LabVIEW projects, but it's an interesting sort of comparison. So what we have here is failed projects. Challenge projects. So a failed project is not delivered, not working. That's failed. So that's really bad. And these are £1 million plus projects. Challenged is delivered late or without the full functionality. So again, that's reasonably bad. So these two blocks here are the ones that go badly, and the green ones are the ones that go well. So you say, oh, well, that's not LabVIEW, is it? LabVIEW projects are different. Well, I don't know, it's interesting, because I think if you did the same with LabVIEW, I think it would be a different graph, and I think that's where this becomes interesting, because I don't think you get so many failed projects. I think you get as many challenged projects, but I don't think you get as many failed projects. And there's a reason why, I think. This is my theory. This is another good presentation. I'm looking through it now, but I've got lots of videos and stuff. He's a bit sweary, but he's got some very good points. He teaches OOP. But essentially, this presentation, he was saying that, you know, it's just everything is wrong. everything he does is wrong. Teaching OOP is really hard because it's not how computers work. So you get a kid in front of a computer and you say, think about dogs and cats and mammals and stuff, and they don't know, it's actually better to teach technical things. So but his conclusions are, what he wants is a way of writing software that is empirically based on usability, easily taught to beginners, still powerful and deep, fits within computation, has real-world analogues. Well, that's kind of familiar, isn't it? That sounds very much like this to me. But the question is why? I love LabVIEW. Why? Why do people like it? Everyone likes their own language because it's comfort blanket. I like my baggy stuff. I like that stuff. But I don't know. There's aspects to LabVIEW again which I feel are a little bit different. So, what are the strengths? So, what are these? It kind of feels natural to do. So, what it's a block diagram looks, everyone can understand it. I can't remember what one is. It's clear and easy to think. Fast to produce, which is an interesting thing. Links. I can't remember what else. I ought to read my notes really. You're protected from the memory, which is an important one. But the most important one is that, fun. That's peculiar. That is, and there's a paragraph in our book. We say, it's fun. Now, why is it fun? It's work. It's not fun. I can think of loads of things that are fun. It's not work. But it is, and there are aspects to this particular way of working that can be thought of as fun. And I think it has to do with this. I'm going to run through lots of ideas now, and there's no computer science really on any of this, so a lot of it is up in the air. One of the main points flowing through this rest of this presentation is this one of immediacy. You can feel what's going on. You do something, you see it. And it seems very easy and dumb and there's nothing much to it, but it's actually, well, we'll see in a minute. So, a programming environment can also convey the experience of immediacy, drawing the programmer closer. So you have an idea, you see the action, you go round and round and round. So back talk, so there's one of the few materials I found. It's listening to your tools and materials. So back talk is a necessary condition of reflection in action, just as immediate feedback is a condition for flow performance. Flow performance is a key thing to hold on to. I have a slide on that in a minute. But flow performance is the reason I have mouthfuls. So, this chap here is a guy called Brett Victor. He used to work for Apple, and he did the UI for the iPad. And if I've remembered to plug in the sound, no I haven't. I'll just show you his video. It'll work. Wrong bit.
I've spent a lot of time over the years making creative tools, using creative tools, thinking about this a lot, and here's something I've come to believe. Creators need an immediate connection to what they're creating. So that's my principle.
The binging is me loading loads of things. Oh dear, I've got, oh dear me. Oh, something's bad's happened. Oh, no, it's VS. Oh dear. Sorry, my player has gone wrong. So straight away, this is 2012. This is a JavaScript, and this has had 1 million downloads. This presentation. It's worth a look. It's kind of interesting. Now what he comes up with is.
So to begin with, let's think about coding.
So he's doing it JavaScript.
Here's how coding works. You type a bunch of code into a text editor,
brilliant.
kind of imagining in your head what each line of code is going to do. And then you compile and run, and something comes out. So in this case, it's just JavaScript drawing to a canvas, and it draws this little scene with a tree. But if there's anything wrong with the scene, or if I want to make changes, if I have further ideas, I have to go back to the code. And I edit the code, compile and run, see what it looks like. Anything wrong, I go back to the code. Most of my time is spent working in the code, working in a text editor blindly, without an immediate connection to this thing, which is what I'm actually trying to make. So I feel this goes against this principle I have, that creators need an immediate connection that they're making. So I tried to come up with a coding environment that I thought might be more in line with this principle I have. So what I have here is I've got this picture on this side, and the code on this side, and you know, this part draws the sky, this draws the mountains, this draws the tree, and when I make any change to the code, the picture changes immediately. So the code and the picture are always in sync. There's no compile and run. I just change things in the code, and I see things change in the picture. And now that we have this immediate connection between the code and the picture, we can start thinking about ways of changing the code other than typing. So for example, this number here is the length of the branches. If I want to control that number, I just point my mouse to it, hold down the control key, and I can dial it up and down.
Okay, I'll stop there.
So I can see what it looks like for big branches or small branches, and I can...
Because that's a lie. Because that, in this code, is a double. And you can't have a slider with a double to represent branches. It has to know what a branch is for it to be the right size. Because otherwise it'd be tiny, because it would be like between 2 plus or minus 2 billion or something. So this whole thing is kind of a lie. This is it's just he set it up, and it looks brilliant, brilliant. The JavaScript people went mad for this, absolutely mental for it. Well,
kind of converge on what feels right to me artistically.
Where's the mouse?
And this works for any number of the code. I just point to it, dial it down.
Oh, this is confusing me now. Hey, there we go. So, in essence, what if rather than we plan out everything, we experiment? What if rather than remember all the details of everything, it's just as easy to test it? What if the language we use is dynamic enough that it breaks the traditional programming paradigm? The mouse again. Where is he? Come on. You know you want to. There it is. Hold on. Okay. So I rewrote this thing in LabVIEW. And this is just me going through the process. And we've kind of already got it. The things that LabVIEW does, it's already there. You can interact with your program, you can bring it up. Check the block diagram, pull it out, all this nice interaction. This, you know, we've had this 36 years now. Maybe it wasn't as simple actually, 35 years, the first one. And you can change stuff. So all I've done is rather than have constants, I've pulled them out. But it's nice. And the most interesting thing is, after I spent all this time, is people are singularly unimpressed about this in the LabVIEW world. And that tells us something very interesting. Jack Dunaway said this. He goes, the most interesting thing was the reaction in the crowd. Oh, so what? Well, this is it. This is the big thing to me. And must be an easy way. Lock. So if you go to the LabVIEW 1.2 manual, it tells you how to wire up a block diagram. And then say, experiment with the new instrument. Try changing the values. Blah, 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 blah. Experimental was key in this early one. It's quite nice, this manual, because it tells you some of the early design decisions.
This was before PDF because it's scanned in.
Yeah, yeah, it's all wonky as well. It's great. It's really, you can still get it.
Yeah.
You can still find the manual. So we go on to another, there's two types of immediacy. So temporal immediacy. In programming, delay between an effect and observing related events or the data in the program puts a strain on the programmer's short-term memory. To hold all the relevant information in their heads while waiting for the program environment to catch up. In Einstein's stats article on bug war stories, 15% of bugs are directly attributed to temporal distance between cause and effect. That's a big number. I mean, again, this is all text-based. But, well, I then, further on in my CLA Summit, where Jeff Kadowski was in the audience, I said, it would be a really good idea if you gave us a buffered VI that we just switched it on, it saved all the inputs and outputs, and then we could wind through it and check the block diagram of all the inputs and outputs. I said, that would be a really good idea, I'd really appreciate that. And Jeff Kadowski, being a polite sort, muttered to Stephen Mercer, he goes, we've had that a long time. So I'll just demonstrate it and apologise, this is my penance. Come on, I might do a YouTube from that, that'd be cool. So, where's my mouse? Excuse me. There we go. Right, this is a bit quick at the start, so I'll just start again. If you've never seen this, well, who knows about this? Anyone? Mikey does. What should happen when you press log, it should come up with a file dialog. I've already prepared this one. So you go log, and then you go log at completion. So here I'm running a couple of servers, a server, and I'm kind of interested in the client, so this is a real-time unit checking up data. I'm interested in the data being passed back from my client. So I'm just going to do some stuff on my program. It's just so that it generates messages to my VI. And all the time it's logging all the inputs and all the outputs away in a file. It's kind of really cool. Just let me give it a few things to do, and I'll quit out and I'll show you the options. So now you go into operate, you can go data logging, retrieve. And look, there's all my frames, 79 frames. Go bit, bot, bot. Ooh, got a bit of a problem there, I've got a few errors being thrown.
So is this each time it's being called, it's logged what the
Yeah.
outputs were?
Stuff's it away. But doesn't stop there. So that's cool. But what would be kind of nice is if you could take all of that data and puke it out into a VI and use it for stuff. Come on, me. Come on, robot hand me. Hurry up, I'm bored of this bit now.
There we go.
I think I was looking for something then. I started going through it thinking, oh, what's this doing? Okay, come on.
What version is this?
Close the back. Show you a minute. So this is 2014. But look at the controls. There's a few clues there. What the controls look like. Okay, for some reason I decided to go all the way through it all. Right. So now you can do something else. Let's just look up. So you go right click on there, You go, enable database, and you get this funny thing. And then you go. Every VI does this. Can you guess what it is yet? Oh, I shouldn't do my French average impression, should I? Too soon. Dum-de-dum. Ta-da! Boom shakalaka. And there it all is. How cool is that? Well, a few times. Oh, there we go. Oh, go away. It's all right. It's not. It's not behaving. Well, going back to LabVIEW 1.2, you can see a very similar looking affair. So sorry, Jeff, I've been bad.
So they really have had it a long time.
They have had it a very long time. Yeah. So, that's temporal immediacy. That's quite cool, I like that. So spatial immediacy is a physical distance between causally related events is kept to a minimum. So the reason it's the same for temporal immediacy, events widely separated in space and screen require users to devote more conscious effort to link to them, forcing them to shift attention, put a strain on short-term memory. I have an example of this coming along because something I was working on disturbed me, why I kept losing my way. And it's all to do with hierarchy, but we'll come to that because that will be in the examples. So there's a lot of terms floating around. Reactive debugging is quite a nice one, but they all kind of mean the same things. But what I'm going to do is I'm going to throw out all of these terms, and these are all the ones that I found looking around for this type of thing, and they're a bit bugger all, to be quite honest with you. But reactive debugging, that's all right. So, traditional programming is based on Platonic thinking. Is you have a theory, you write the software. Dudoosh. It doesn't work, you have another theory, you write the software. Dudoosh. Now, I think one of the strong things about LabVIEW is that you don't need that. I think, and again, this is another term by this opinionated gentleman called Martin Fowler. And conversational software. I like this one. This is quite a nice term, and this I've always thought of. I've never really thought of the inside of it, but I've always liked being able to sit down with a customer, write code in front of them, take requirements from them, carry on writing code. I've always thought that was the huge advantage of LabVIEW. So making rapid changes in front of the user, involve the user in the process. This is agile, but it's 36 years old. So I would say the things in the Agile manifesto which I quite like, LabVIEW can do it all. So we and our customers learn as we go, and that's important. See, that's the other thing. The customer doesn't know what he wants until you show him what he's going to get, and then he knows what he doesn't want, and then you show him what he's not going to get, and then you just you go round. That's, again, a huge advantage, and it's just about as agile as you can get. Flow state. So my little highlighted thing talking about flow state. So this comes from a TED talk. I'm not even going to bother saying his name. But he's a clever chap, and he deals with musicians and artists. And he says it's a challenge skill to get into the flow state. So essentially the flow state is when you lose track of time. You're busy working, concentrating, losing track of time. Your challenge skill balance has to be correct for it to work. To get into the flow state, you have to do all of this stuff. Merging of action and awareness, clarity of goals, immediate and unambiguous feedback. Concentration on task and hand, paradox of control, I can't remember what that meant. Transformation of time, loss of self-consciousness, That's why I get mouthfuls, as I'll explain in a minute. And autotelic experience. And I had to look for what autotelic was. Oh, it's you're in control of your own decisions. You're in control of your own destiny. It's that stuff to do that. The loss of self-consciousness is, I get mouthfuls because I stop swallowing when I work. And I can do this for 2 hours, and you suddenly, oh Christ, my tongue's stuck to the side of my mouth, and it's hideous, and that's why, it's all self-inflicted. It's a self-inflicted wound, but that's the loss of self-consciousness. And any of these things will affect that flow state. That is your maximum rate of working. This is your most productive rate of working when you're in this state. And any of those will stop it. So, debugging while programming. This is why debugging is great. So when I'm designing a UI, I want to be able to quickly see how my changes affect the field. So if I'm sat down with a customer, I don't have that many preconceived ideas about what they want. Drag and drop. Nah, that's not going to work. Let's have a list box and a button. That's going to be much clearer. Those decisions are much better presented to the customer at the time. Also, I think you're really good if you do that. I like to think now that I'm a designer, not a programmer, and LabVIEW is more of a design tool for me than a programming tool. I need to be allowed to play. Who knows which way out a 2D array goes into an index, and who's ever looked it up in the manual which way it goes in? No, you don't. You do it, you have a look. Oh, it's that way. And I still do that now. And I can only speak for me, because this is a sample of one, have a cause and effect brain. I have to see the cause and effect. I learn by cause and effect. It's a constructivist way of learning, apparently. There's a whole heap of work, and it's very interesting. So there's this educational philosophy called constructivism, and the book that tells you about this is called an educational book called Mindstorms, which Lego Mindstorms gets its name from, which is run by LabVIEW. The advantages is we're not locked into our domains of expertise because of this, because we can experiment. We can go places we never thought we could go. So this is my kind of career. I started in transducer test, commercial test, aerospace test. LabVIEW real-time came along. Suddenly, data logging, factory control systems, I'm doing those now. Laboratory management, I cracked that. Then FPGA comes along. Distributed control systems, more distributed systems, machine control, distributed logging systems, machine monitoring systems. Pretty much now, I would say that bit is most of our business now. That top bit we don't do much of now. Databases coming in there, the addition of this. So you learn all these extra skills. And I'm not saying just in LabVIEW, in any other language you would learn these skills as the jobs come up. But because you're churning out code rapidly, systems rapidly, I think that's accelerated. And I think it allows us to tackle areas which we never thought we would go into. Imaging, image acquisition, stuff like that you could put that up there. There's so many other tools that you can add on to this. So, how do we hinder LabVIEW then? So, LabVIEW gives us all these great stuff out of the box. And then we go and cock it up. So, thinking about how LabVIEW works, if your architecture removes these advantages, you're wasting time. It's becoming less effective in what you do. Again, this is only my opinion. If you have a brain that likes everything listed out and you do it like that, then the way you work might be better. One simple way, so this is actually the simplest VI in LabVIEW, we can see it, just runs. Now, this term here, functional VI, again I'm throwing up another load of computer science. I don't think we should use that term, purely because there's a war going on with functional languages and Oop at the moment, and it's nonsense. So, using James's term rather than my last term, which was a bit more clunky, a non-testable VI. It's a VI that don't run, essentially, that's all it is. You cannot run this VI because you've got to have a variant input. So, in very simple terms, I've made a trade-off here. I've said, for the convenience of having a variant input, I've lost the ability to run this VI. And I think there needs to be an additional design decision, which I'll talk about in a minute. So this comes down to this graph. A computer scientist's main challenge is not to get confused by the complexities of his own making. So, the difference between complicated and complex. Life is complex. You can make it complicated. So, if the problem is this complex, the solution is that much more. It's going to be this complex plus a bit. How far over you go has ramifications for your design, has ramifications for your maintenance, all of these decisions. So if you are coming up with a very, very complex solution to quite a simple problem, obviously it's going to be quite difficult to maintain. The one I've run into, this is the other one I highlighted, which is Spatial Immediacy. I've got a VI that is an oscilloscope and it's dynamically dispatched. It's a hardware abstraction layer, blah, blah, blah. So when I go looking for it on my block diagram, I bop it up, polymorphic VI, click on the right one, bop it up, oh, it's a class, bop it up, it's a subclass, bop it up, and there's the method I'm interested in. And that I find very hard, and it's only me, but I find that breaks the immediacy of what I'm doing. And it could be, maybe the IDE could help us a bit more here, because it knows how you ran. It should be able to load the one that ran last. But, there's that I find a problem, and it does drive me away. I've got a similar thing for my configuration abstraction layer, so you've got different ones, blah, blah, blah. And I've taken it out and gone back to just, you just use a database. And that's it. Because I don't want these layers, and it disturbs me when I'm programming. So being positive, he's got some nice words, Ned Chaplin. So comprehension is the most important factor of doing maintenance. If I can actually find that page. There's another few here. It's called reading before writing. So Harlan Mills said software should primarily be designed to be read. I'm really big on this. Once you've sacrificed readability, it's really, really expensive. That catches up with you so fast. So this is the battle that's going on. This is why I don't use the term functional VI. Oop, and functional. Functional programming is a mathematical way of setting up your system so that it doesn't have any immutable objects. It's so bloody complex to explain, but lots of computer science types get very excited about it because one advantage of it is you get functional reactive program, which gives you immediacy. And that's one of the reasons they use it. It's mathematically correct as well, but that's just nonsense, really. The functional reactive programming is what they're aiming for. It's languages like Elm and that are coming up with ways to get that breadth vector screen. So I'm not going to use functional VIs for this. I quite like the term immediately testable VI. And that's kind of a simple concept. So essentially you take the bits that you can't run and you make a VI of the bits that you can. And that's it. This is my big woo. But it's kind of, I don't know, it was kind of new to me because I would put all this stuff into a VI that wouldn't run. And then I couldn't really test it until I had it as part of my entire framework running. So it's changed the way I program slightly. So, and you could say it's more cohesive, less cohesive, is I'm splitting out the bits that don't run and pushing them into bits that do run all the way along. So what I can do is then I can go VI, 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 they're all empty shells just with the inputs. I go run, call all my stuff from the database, then I do all the work because I've got all the data there. And that's the flow of the programming. Again, kind of simple, but. So, what should be immediately testable? Well, it's actually some quite important things. You know, all your decision making for flipping into states on a state machine, you should be able to, having those immediately testable and testable via, you know, a unit test framework or anything like that, is really handy. Even using the data logging thing, having all your options. Array handling, parsing text, I use parsing text a lot, maths, all of these things, I think you should split out and make immediately testable. Right, going into the immediacy of your block diagram. Now, I'd quite like, and I haven't really explored it too much, is when you consider user interface design rules for your block diagram. Because your block diagram is the user interface to your code, really. Being able to navigate your block diagram to get this flow state is really important. So I quite like putting things in like, put a control in their event, because then you can right click on it and go, oh, that's where it's being used. You know, it's just, that's how I like to work. I go, front panel, block diagram.
I was wondering why you couldn't right click on the event and say, where is this control?
Yeah.
I mean, I will go through code like, oh, they've got this thing, where is this
Well,
thing? And then you can't find it.
And the thinking, I think, that again, that came out of this is because I just used the tool previous to starting to think like this. And it's a very small way of changing your thinking, but I started thinking like that. I started thinking, well, why can't I move this step, move it back? I've taken my, well, I've whittled down my ideas because I got caught out. Searchable. So again, keeping things searchable, constant VIs. And of course in LabVIEW 2015 I've got a filter on the search now. Bonus! Local variables. I don't use local variables there, race condition, blah, 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 blah. The problem with this block diagram isn't local variables. The problem with this block diagram, it's shit. We use local variables. They're great because you can search them. I know there's an extra weight, but computers are big and fat now. Extra weight, we're not working on embedded systems. The money is there for us. I can search all those now. It's great. But they need to be in small controlled chunks of data flow. That's where you get race conditions, is because, you know, local variable updates here, and over here in the block diagram 4 miles away, something happens. And, oh, I got a race condition. Well, you will. Don't make shit block diagrams. And again, going back to the ideas thing, I'll tell you a story about this. So one of the ideas I had was you could, oh, what's it going there for? Ideas, queues, right. It'd be nice to be able to right click on a queue and actually see it like they do on the event structure, because you can do the same sort of thing on that and get a list of the queue data going in. There's preloading variant, preloading objects into a VI so that you can actually run it without setting it up. That kind of thing, preloading object data, would be really nice and would improve the whole experience. The stuff they can do with the visualization sort of side of the program, now that hasn't changed in years and years and years. You know, I'm thinking about this, how can I speed up the feedback from my block diagram? How can I get to it? Actually, it's not being thought about, and this is what I'm saying, there's not a lot of computer science about this. So I think, and this is only my opinion, when people talk about LabVIEW's advantage, oh, it's graphical. HPV was graphical. That's not the reason. Data flow is the other thing. Well, the first thing you do when you get beyond a certain level is break data flow. So it can't be the only thing. So the iteration of rapid debugging is actually a more natural way to program. I think it's the natural way to program. The immediacy in the idea allows us to explore different domains. I think that this learning, you're learning from your code, you're learning from your project. To make our lives easier by splitting non-runnable and ITVIs. Think about navigation and searching and moving about your block diagram. Consider block diagram time when breaking data flow. And consider UI rules. This is something I need to look into more, but signifiers and things like this in your block diagram. So I'm doing this leads on to this, and being able to group this sort of stuff together is kind of another area that I'm interested in. It's quite hard work, so I haven't done it yet. So in summary, LabVIEW is really good to debug with. This is a real advantage. Design decisions we make can affect this advantage. Be kind to your block diagram. LabVIEW is quite different, and it's pretty much ignored by computer science, I think. So perhaps us users ought to be coming up with more feelings of this type. And there you go. That's my presentation. Any questions? Marvellous.
Yeah, I've got one. The slide on queues.
Yep.
Were you trying to say that queues are difficult to visualise because effectively you put something into a queue and it pops out over here, and
Yeah.
you need a way of seeing that?
Well, they've provided it for events, haven't they?
Yes.
That same tool. In fact, that's what I cribbed. You'll notice
You
this.
could do that with a custom probe. You can make that.
Yeah, but I don't want to make custom probes.
It's still not that
That's the
visual thing, though,
IDEs.
is it? It's still not that visual, I can see what's happening.
Yeah. No, I agree with you. I think there's a lot more that could be done. So,
Jeff's wire might be some way to address that.
don't know.
So,
I don't know. I think Jeff's wire brings.
Isn't that confusing things more? Because we're now breaking what we've spent so long learning.
Well, I
just pop out.
I like Jeff's wire. Have you ever seen Jeff's wire? It's a way of jumping out of a loop into another loop by a wire. Essentially, it's a bridge. I think it's done by queues under the hood, isn't it? So it's essentially it's a queue that talks to another queue, but it's visually it looks like a line coming out of one. And I think if you have a master-slave setup, you set them side by side. That's brilliant. But of course, that's nice visualization. But you're making that nice visualization by spacing it on the block diagram. What if I then take Jeff's wire and stick it into something that it should be stuck into, and then wire over here in this massive block diagram, and then it will get blamed for making the block diagram hard to understand. Well, it's not actually the wire's fault. It's again going back to the block diagram being hard to follow. So, I mean, I've not really gone into anything more than my initial sort of ideas with this. I kind of wanted people to start thinking about how they use the tool, because I see too many things in LabVIEW going over to the project now, and the block diagram is where you should be programming, not the bloody project. Honestly, I see that as the bad tool to do programming. Any more questions?
Constant in a sub-VI is very, very useful,
I like that.
because otherwise you end up having to use VI scripting to write something that search through all of your code to find constants.
Plus, you've
Yeah.
got a large,
Which isn't a trivial thing to
plus
do.
you've got a large cluster. It's you can make the VI
The
really small.
thing I like best about it is I linked Subversion so that it would run a little script in VI and change the version. My constant VI, which was the version number. And that was quite cool. So you have it all linked. You go, here's my comment.
Push compile, takes
Yeah.
you 3 hours to compile a big version,
Yeah.
and you realise you forgot to update the number.
Yeah, it's a nice trick. I can't say that I use it all the time, but it's there. And you can
If you get
very easily change the
yeah,
constant
no,
value
no,
using
no,
script.
but yeah, okay.
if you suffix it with something like dash dash constant, as well, then they're really easy to find in quick drop.
Yeah.
If you're in your project and you just control space and
Yeah.
drop dash dash constant, you'll get a list of all your constants in your project.
Yeah. I mean, we try not to keep that many. I think the only constants we really keep in projects are the version number, because we think constants should actually be part of the configuration if possible. So, yeah, there you go. A flight of fancy for the first one. What's next? Coffee.
I don't know what's next.
Yeah, yeah. Not necessarily real time.
What time was that? That was about on time. Yeah. Wow. Unbelievable.
No, I like the point about the testable stuff. You always end up doing it. It's like you got this. I'm going to make something like that because I need to work out whether it works or not.
I never formally did it, but actually as a design process, it's changed slightly the way I program. VGA. It's VGA.
Oh, when I had VGA on the other side, I remember I had a problem where I couldn't hear the screen.
Oh, that's why.
There's no VGA.
No, it's only VGA, I think.
When I test
Giant mouse. You want that? Oh, copy.
No. He had to retake his CLA, did he? Yeah. Passed, but
mind if I test my laptop? I'm talking to one.
Oh, one next. Yeah.
Oh, isn't it? Should I copy it?
Yeah.